Okay, hi, I'm Eric Brynjolfsson. Welcome to the Stanford Digital Economy Lab lunch seminar. We're delighted to have Alex Tamkin here. He did his PhD and undergrad here at Stanford, and now he's a researcher over at Anthropic, where he's working on understanding the societal impacts of AI. And in particular, this amazing project that he's going to talk about now, which economic tasks are performed with AI. Welcome, Alex.
Thank you so much for having me, Eric. It's really great to be back. Like Eric said, I did my undergrad and grad studies here in this building. And so it's really nice to be back here to share some of the research I've been doing. During my studies here, I focused more on the building AI and AI methods. And here I'm looking at the capabilities and the societal impacts of AI. So the work is called Which Economic Tasks Are Performed with AI? Evidence from Millions of Claude Conversations. And this is work that was done with many, many folks across many different teams at Anthropic, especially the societal impacts team, and was co-led with Kunal Honda, who also had done some research here previously. And it was a really fun interdisciplinary collaboration. So this is a part of a broader effort at Anthropic that we're doing called the Anthropic Economic Index, which aims to really track and understand AI's impact on society, the labor market, productivity, and its effects more broadly on the world. And so it's part of a larger series of research papers and data sets that we are doing in order to support work in this space. So we're starting from a few basic premises here. The first is that AI is already starting to have an impact on the economy. It's being adopted at a very fast rate among consumers. It's seeing steady adoption across businesses. And there's lots of discussion in the public domain about its effect on productivity, its effect on employment and the job market. And when you look at this impact, you see that that impact actually is many, many small impacts that are stacked on top of each other. It's the impacts of the underlying compute infrastructure that changes the models. It's the underlying capabilities of the model and the advances that are trained on more and more data and compute. It's the ability of these models to be fine-tuned for many different purposes, its ability to be deployed across many different products, and its ability to actually end up being adopted and pass through these organizational barriers to adoption. So all of these impacts are occurring and are gradually increasing over time. But if you ask a bunch of economists or people who work in AI labs or business people, and you ask them what they think you get 10 of them in a room and you ask them what the economic impacts of AI are going to be, you're going to get 11 different answers. And that's because the priors that these people come from are just so different from one another. It can't be resolved just by theoretical arguments. It needs to be resolved with data. And so what's really great is, while there's been a lot of fantastic research that tries to predict what the effects of AI will be on the economy, for the first time, we can actually start to track and measure this phenomenon in a bottom-up way using real-world data. So Anthropic makes Claude, which is one of the leading and most capable language models. And we can actually use privacy-preserving analysis methods that we've developed in order to open this black box, so to speak, and share what we're seeing about the use of these models in the broader world. So the plan for today that I'll go through is we're going to talk about how we map Claude.ai conversations to tasks in the US Department of Labor's ONET database. Then we're going to find what occupations have tasks with the highest usage. And then we're going to do deeper insights and analysis into how AI might impact work in the future. So starting from the first one, the ONET database, for those who aren't familiar, is a large database maintained by the US Department of Labor. It consists of occupations, hundreds or thousands of occupations, including data scientists. Each occupation has a number of different tasks associated with it, right? So data scientists analyze and manipulate data. They create graphs. They apply sampling techniques. It also has things like the median wage of that occupation or the barrier to entry. How many years of study are required before you can perform that task? So you also have anesthesiologists. Higher median wage, tasks like administering anesthetic and sedation, recording the time and amount of anesthesia, providing life support. college history teachers, providing and making course materials, advising students, right? So you really get a full picture of the use of the potential for places where AI could or can't be used, right, through this data set. And what we're going to do is we're going to use Claude to help understand how Claude is used. So given a conversation, like, can you take this data and make a nice stacked bar chart for me, right? Claude will say, yes, I'd be happy to. Here's the code. And then we can ask Claude, hey, here's a conversation between a user and an AI assistant. What was the conversation? And Claude will say, looking over all of these 17,000 different tasks in ONet, the best fit is create graphs, charts, or other visualizations, right? And we do some analysis to actually verify, using data that we have permission to look at, that this Claude actually does a pretty good job here. So more details, right? We filter Claude conversations to conversations that might possibly involve an occupational task, according to a language model. But fundamentally, these tasks could still be side projects. This could be a non-statistician who needs to make some graphs. It could be a statistician who's doing it on the weekend on some data, just for fun. And yes. Yeah, of course.
So on that first bullet, possibly involve occupational tasks. I hadn't really thought of that before you had that bullet up there, but so some subset of the things people are using Claude for are going to map to ONet, and others are something else. They're helping, I don't know, cook a meal or something. Do you have a sense of how many are in those different categories?
Yeah, I don't know whether we have that breakdown in the paper, but for example, people might just say, "Hi, Claude, how are you doing?" Right, and that might not be a task. Cook a meal might actually map onto food preparation and advice on food preparation, which gets into a second point, which is that
I was thinking like household tasks, but yeah, also
totally, yeah, exactly. So there's some solid chunk that's basically Claude says, yeah, this is probably not involving an occupational task. Although we do a second report where we actually look at the difference of doing that step and not doing that step, and the overall distribution of tasks looks pretty similar.
Here's a slightly harder version of that question.
Yeah.
What about tasks that probably are part of an occupation but don't map to one of the ONet categories?
Yeah, that's hard. And that's why in a follow-up work, what we do is we actually do a bottom-up taxonomy. So rather than just mapping all of the questions that people are asking Claude onto ONet, we can actually look at all of those questions, not with respect to a top-down data set, and have a tool that we created called Clio actually come up with these bottom-up tasks. Right. So this usage, which seems to be associated with work or work-related tasks, even if it's not being performed by a statistician, it still reflects emerging work-related uses of the technology. And if done by a layperson, if this is a situation where you have expertise on demand, it could affect the demand for statistician labor, right? And so these are reasons why we still think these measures are pretty interesting. Additionally, this is for our chat product, Claude.ai, not our API product, right? We wanted to start with chats, which are a very easy and useful and much more homogeneous data source to analyze and understand. And we'll get more into this later, but we've open sourced a data set of these counts and a lot more. You can find it on our Hugging Face page at Anthropic. And it's really a new resource that we're envisioning that complements job postings data sets, survey data sets, patent data sets, as another way of understanding how AI is being used at the most sort of granular, real-time level.
Did you do the research for the API as well?
We've done only research for Claude.ai and also Claude Code, which is our agentic coding product. Great. So now that we have all of these mappings to 17,000 different tasks, we can then, each task is associated with an occupation in ONet. And we can map those tasks, right? So like modify software to improve performance, we can map that to computer and mathematical occupations, the SOC major group. Or rewrite and review and rewrite content that maps to the arts and media major group, right? And what we find here really lets us paint a picture of the Claude economy versus the US economy, right? So those gray dots are the percent of US workers across each of these different SOC major groups, right? Everywhere from office and administrative support all the way to farming, fishing, and forestry. And what's really interesting is if you look at the top use jobs and occupations in the US economy, these are a lot of things that require in-person relationships, moving things in the real world, right? But and so they show high usage in the economy, but lower comparative usage on Claude. Claude does not have a robotics product, right? We are things over a digital interface. On the other hand, software engineering, computer and mathematical occupations, 3% of the US economy, almost 40% of the Claude economy, right? And this is for a few reasons. One, the models are really good at coding, right? This is for a number of reasons, including the fact that coding is a thing that you can just check the answer to quite easily in a lot of cases. Two, coders are always going to be among the first adopters of new technologies. It's a cultural factor, not just a technological factor. Coders are typically more willing and open to try out new technologies, especially digital technologies, and adopt the technology into their daily lives. But three, there's also organizational barriers to adoption. If you're a doctor at a hospital, you can't just take a screenshot of a patient's medical records and put it into a chat product, right? You have various regulations that prevent you from doing that because it might have implications for patient privacy, right? And traditionally, also, you have these larger and centralized procurement processes, which can take 18 months, right, to start the process of scoping out different potential vendors, to identifying them and whittling them down, to trialing them, to then actually making a purchasing decision and making it available for people, right? So these are a few reasons why coding, you see a huge amount of usage, even though you see quite strong performance in other benchmarks, including medical benchmarks. But we don't just see usage in coding, right? When we started this research, I thought that we'd see maybe a majority of usage in coding, but I was really surprised at how long the tail was here. And so in particular, we see a lot of usage for writing-intensive occupations, for copywriters, for editors, for translators, and also science use cases, life science, physical science, social science. We see people using it for coming up with new material design techniques, for doing economics research, for trying to understand quantum mechanics. So we see a lot of usage for the sciences as well. This gives you another view of the data. So for computer and mathematical occupations, we see tasks like developing and maintaining software applications, for debugging code, and these are associated with computer programmers and software developer roles. For arts and media, we see technical writers, copywriters, editors, tasks associated with these occupations, right? Like maintaining comms and media strategies, or developing multi-industry marketing and promotions. We also see high usage in education, right? For things like designing educational curricula, for managing book and document publishing. When I was writing my thesis, language models, maybe they can help you format the citations, or help with a lot of the document processing that's needed there. So that's where AI is being used in the economy. But there's also a question of how deeply is it being integrated into the economy and into different jobs, right? There's a big difference if your job has 12 different tasks and you use AI for one of them, versus AI is simultaneously being used for all 12 of those different tasks. So that's what this chart shows. It shows that 36% of occupations have usage in at least a quarter of their tasks, while 4.1% of occupations see usage in at least 75% of their tasks. So that might be a task like foreign language and literature teachers, or an occupation, right? So there, you can use AI to help you come up with ideas for classroom activities, for preparing lesson plans, for helping with feedback, for translating documents. But it isn't actually maybe being used for classroom instruction, right? And for actually managing the classroom and for doing discipline. All right, so now that we know where it's being used in the economy, at least where Claude is being used, and we know how intensively it's being used, we can do some deeper analysis into different aspects of how AI might be impacting work. So this is a graph on the x-axis of the median wage of different occupations. And on the y-axis, it's the percent of occupations that fall into these different categories. And that dotted line at around $60,000 is the US median wage. And so what you see is a lot of usage has, all right, I guess I can't use laser pointer. A lot of occupations have very little usage, right, across the whole wage spectrum. But in occupations where you see a large amount of usage, this tends to occur around the upper middle quartile of jobs, right? So whether that's software engineers and developers, computer programmers, see copywriters, bioinformatics technicians. You see less usage in occupations on the very left of the distribution, things like shampooers, food prep, servers, waiters and waitresses, right? Physical jobs require presence in the real world. But you also see less usage on the far right, on the very, very high-skilled jobs, whether that's obstetricians, gynecologists, anesthesiologists, again, for a lot of the organizational barrier for adoption and cultural reasons that we talked about. We also look at breaking down not just where AI is being used, but how. So we can actually look at the interaction mode that a person has when they use AI. So are they using AI for augmentation, or, for example, validation? Can you proofread this article? Can you check my work? Can you give me feedback on this? Is my English right? You know, we see a huge amount of usage of Claude for enabling people to use English, right? And when they might not feel as comfortable with it. We also see a lot of usage for task iteration. And so this is where the model is actually doing a good amount of work for the user, but it's integrating it deeply into the work process, right? It's not delegating it entirely. Can you tighten up section 2? No, I didn't quite like this. Can you change that? Can you work in this quote? Here's my version. Can you adapt it this way? That's task iteration. We also see a huge amount of usage for learning, right? So explain the Baumol effect in the context of AI, right? Like trying to understand and integrate and build skills to enable you to do the jobs better. We also see usage for automation. So we see usage in this category we call feedback loop, which is sort of, you can think of it as fix it for me in a coding context, right? It says file not found, can you fix it? Now I'm getting out of memory, right? This is a little bit different from task iteration because the user is not so much serving as a, you know, where's the, to show the creative direction for the model. It's more serving as a conduit between the computer, between these two computers, the computer and the model. And we see usage in directive tasks. That's more delegating. Things like, can you just translate this for me, right? Can you write a poem for me? Can you do this? Can you do that? So when you take a step back, we see that there's around 30% more on a relative basis, more augmentation than automation in our overall data set. But this is just one approach to measuring automation and augmentation and the ways in which people use AI. And the implications are, I think, really just starting to unfold, right? So something that looks automated to us, something that looks automated to us might empower people by freeing up their ability to do other kinds of work, maybe other kinds of work that they that is more meaningful and more enjoyable, right? Whereas more augmentative usage might make people more productive, thereby changing the demand for human labor, right? In either direction. You could have an effect where the demand goes up because now all of a sudden people are more productive and it's just worth it to invest a lot more, or down if the demand is a little bit more fixed, right? There's a lot more work needed here to connect these sorts of different measures to downstream outcomes that we actually care about, which are, you know, worker well-being, demand for labor, employment, what jobs are actually going to look like in the future. We can also analyze what skills does Claude think the AI, in this case Claude, is using and relying on in its responses, right? So when you say, can you make a stacked bar chart for me? Then Claude says, well, what skills in ONET are used the most in this response, right? And so what Claude says is that it finds that critical thinking and active listening and reading comprehension and writing, these are skills that are used the most. Claude will ask you follow-up questions. That gets blended into active listening. Claude will do things that require some amount of critical thinking in its estimation. We don't analyze whether that usage is advanced critical thinking or simple critical thinking, but deciding on what the right bar chart format is, qualifies. And Claude is, obviously needs to read and write in order to do its responses. On the other hand, we see much less skills relating to repairing things, operation and control, equipment maintenance, negotiation, installation, selection of equipment, right? This gives you an early window into potential complementarities between skills that people are good at and are able to do and skills that models are increasingly being able to do. Again, just a sort of first pass at this question. We also can use this analysis to facet this by model. So which tasks do people delegate to different models? So we can look at Claude 3.5 Sonnet, which at the time was our state-of-the-art coding model, just state-of-the-art model in general, but especially good at coding. And we see that people prefer it for usage in all sorts of coding tasks, whether it's designing database systems or programming or developing software applications. And we can compare it to Claude 3 Opus, which is an earlier generation model, but that was sort of renowned for its character and personality and its ability and use for writing and creativity. And so you see more usage of it for educational materials, for conducting academic research, etc. All right, a lot of limitations here. The first is that our data sample is just Claude.ai, right? We don't have information from what the full spectrum of different companies out there are doing, right? People go to Claude for a bunch of different things. They might go to ChatGPT for other tasks. They might go to Gemini for other tasks, right? These are fundamentally, we won't have a full picture of how AI is being used across the economy until we see, other labs open up their data in the same way, right? We use Claude, obviously, to monitor Claude, right? This is the question: is the fox guarding the hen house here, right? Ultimately, we do a lot of hand validation on data sets that customers are giving us permission to look at. And we find that the performance is actually quite strong, and we share more details about this in the appendix. But nothing is perfect, and there might be tasks that don't fit into the ONET database, et cetera. We don't look at query complexity here, right? We don't look at whether someone is asking for help making an omelet, or whether someone is asking for help for the logistics of how to plan and execute a 500-person feast for a wedding, And so basic cooking questions count the same as expert-level tasks here. We use ONET. We're starting to make progress on this, and I'll talk a little bit more about this in a few slides. But it's a static database that doesn't capture the sort of emerging AI-generated, AI-enabled jobs, right? It captures the jobs of the present, not necessarily the jobs of the future. And fundamentally, we don't know how the outputs of AI are being used, right? We see that people are using AI for something, but we don't know whether they incorporate it into their daily job outputs or into a report. Does that make the company money? Do they get promoted? Does it make the world a better place? That's not something that we know at the moment, given the information that we have.
Are you doing anything in terms of overall market development?
Yeah, so all of our data is released online, uses the ONET database, and I think it creates a really nice standard that another company could use the exact same procedure that we lay out in our paper. And researchers like you all could join on it perfectly. So I think that's a sort of really nice way that we're just relying on pre-existing standards. Yes, there is, and we have done several reports since this initial report where we dig into more details. In particular, we had this feedback and input form where we sent it out and put it on our website, and tons of economists, including many in this room, thank you, had feedback for us. And we took that into account, and we used it to shape what we did in our second report. We looked at how things are changing over time, right? So just in a 2-month window from December to February, but we saw even more increase in coding usage, in education usage, in science usage. we looked at how these varying interaction modes varied by task and accordingly by occupation, right? Computing tasks skew more towards 50-50 augmentation automation, right? Sciences, business, sales, healthcare, those are more 75% augmentation. Or occupations, we see usage in physical tasks, right? What's happening in those physical tasks? A lot of learning how to do those physical tasks, right? How do I fix a toilet? How do I do this? How do I do that, right? Because Claude can't actually go and do it itself. If you look at task iteration, for example, and we break these out in more detail, you can see the rest of these graphs in our blog post and in our report. Writing heavy tasks, I thought that we would see a lot that writing heavy tasks would be very automative, that they'd be very directive. Just write this thing for me, just do it for me. But really, you see a lot of back and forth, detailed iteration, and fine tuning of prose rather than just using whatever pops up out of the model. The copywriter's tasks, editor tasks, instructional designer tasks, a lot of augmentation and deep interaction there. There's a whole new class of models called reasoning models, right? Which are trained to think longer before giving the response, like O1, R1, Claude 3.7. We slice our data by the occupations where we see the highest fraction of thinking mode, of this is extended thinking mode, mostly technical fields, software developers, multimedia artists, bioinformatics, et cetera, right? We present a new bottom-up data set of Claude usage. This is work that was led by Miles McCain, who's on our team, where we, rather than mapping onto a pre-existing taxonomy, we can create a bottom-up taxonomy where we can say, find tasks like help me troubleshoot video and camera applications, application issues. Own it isn't perfect. There's duplicate tasks. The top-down taxonomy, we use this system called Clio to actually map in a bottom-up way this usage across different tasks and occupations. And the Washington Post made a nice visualizer of our data in case you want to search for various tasks and see what the usage is in our data. We also did a report looking at the transition from chat models to agents, right? Agents is sort of a big buzzword. It means a lot of different things to a lot of different people, but there is some technical meat and depth to what it means. And I think it does represent a new paradigm for how we're going to be interacting with models. And so to give you an example of this is what a chat interface looks like, Claude.ai, say create a diagram, you might get this artifact window that pops out, and it might create a diagram for you, and it might give you an explanation of it, and then you have to go and figure out how to integrate that into your work product yourself. That's the chat interface that we have today. By contrast, Claude Code, which is a recent coding agent that we put out a few months ago, this is a model that can actually do the work in the context and place where that work is happening. In your terminal, where coders spend much of their time, you can tell Claude, I want you to change and add this feature to a code base. And Claude Code will be like, all right, let me use a tool to read your code base. All right, let me move and navigate to this part of the code base. Excellent, let me run a few tests. Okay, I see how it's working. Let me add this feature. Is it working? I see a bug. Let me fix the bug. Let me try it again. Now it's working. Great. That would have taken many, many round trips back and forth with the chat interface, right? And the chat interface can be more informative. But agents like Claude Code and whatever the future agents might be for many different use cases represent a sort of paradigm shift here. And so we did work that was led by Michael Stern on our team to actually understand and see that agents appear preliminarily to be more automative than chat. That makes sense. They're doing the work in the context of where that work is actually happening, and people can still go to the chat interface to ask general questions, right? But we're seeing, as you can see here, much more usage for directive tasks. Do this for me, automate this, fix it for me, and comparatively less usage on these more iterative, learn, validate task iteration than you do for Claude.ai. We also can get a window into who is adopting this new paradigm of technologies, right? And so we can use Clio, this privacy preserving technology, to estimate the fraction of usage in code bases that correspond to personal projects, enterprise work, startup work, academic research, open source, tutorial and learning, etc. And what we see is really interesting. We see that startups are adopting Claude Code at significantly higher rates than the usage of Claude Code is significantly higher and more tilted towards startups than Claude.ai is, right? Same thing for personal projects. Whereas you see Claude.ai, which is, again, very new, but the more legacy, or older technique of interacting with language models by comparison is more used in enterprise use cases in academic research, tutorials, coursework, etc. And so it sort of gives us an early window into where these technologies are going to have the most impact, and tells you a bit about the organizational barriers to adoption. All right, so what's the path forward here? So our data is publicly available for everyone to use online, and all of these reports, we've had a new data set and data dump that we're sharing with the community, because we fundamentally think that the only way that we can tackle these really important problems about what the impact of AI is going to be and what we should do about it is collectively, right? It shouldn't be just a few people in the labs deciding it. It should be economists, it should be social scientists, researchers, policymakers together, who all have a window into how the technology is being used and how it's poised to reshape the world. Because you can't really have an impact in steering the ship if you don't know where the ship is going and where the steering wheel is set to, right? We're updating the economic index routinely and periodically, continually, with more research and as models improve. And we hope to really see a broader movement towards research and transparency in this space across the field. To your point, it's really important to get a picture of not just what we're doing, but what everyone is doing, and working together as an industry to make that happen. And so we think that's really important, and more soon on that. So I'll pause here and leave lots of time for questions. I know we have people remotely and in person, and just happy to, field some questions and continue the conversation. Thanks so much.
Thanks, Alex. So I just want to ask, when people ask questions, just wait for the mic so that everyone can hear.
A very quick one. So the first graph that you showed, the delta between the Claude and the American, the very first slide, so what is the conclusion? Do you have a conclusion in your paper? Does the term organic economy kind of come into your thoughts, where the organic economy is the one that the delta is minimal, and non-organic is one which is the largest? And the minimal one is actually among financial, I think, industry, or anyways, what is your conclusion?
Yeah, so I think what this tells us is it tells us a picture of those three different attributes I talked about. One is, what's the technology good at right now? Two, what are the cultural factors that influence whether people are and can adopt the technology? And three, what are the organizational barriers to adoption that might inhibit the cultural people who want to adopt it and the capabilities that the models are capable from actually seeing impact? So what this tells you is, it tells you where you'll start to see most of the impacts first, potentially. I don't make a claim necessarily that the sort of perfect state is where the Claude economy mimics the US economy. I think that goes a little bit too far. I think it's more useful to see, where is this impact perhaps seeing itself first, and what does this tell you about the underlying latent variables that lead to its potential impact or lack of impact.
This chart is Claude.ai, or?
Yes, that's Claude.
Yeah. So actually, could you tell us a little bit more? So Claude Code was a little bit different.
Yeah.
And then the APIs, maybe you can say how many people use that, and maybe just speculate on how different that is. And then you started with the Allow Do It All. That's OpenAI's tools. Do you have a sense that Claude users are different in some way, more coding or something? And just how much should we extrapolate from this to how LLMs are used in the economy?
It's a great question. I mean, I think that the full picture would really require knowing how other people, are using it, right? People tend to really like Claude for coding, so it wouldn't surprise me if you see lower coding usage in across the other model providers, right? People also use ChatGPT for image generation, right? That's not something that we support, so you'd see more usage for some of these arts and creative use cases. But there's a lot of, even I'm in the field talking to a lot of people. I don't really know is most of the usage in ChatGPT education? Is it students? Is it what is it? I'm not really sure, and I think we'll really need increased transparency for that.
They'll do that. How about the API products? Do you get a sense that they're very different or similar?
Yeah, it's a good question. We don't really have those figures here. I think Claude Code, certainly we see a difference in like the environments that it's used, and obviously it's used a lot more for coding use cases. I think there's a potential that you'd see more automated use cases for the API because it's being used in a more programmatic way. But at the same time, a lot of these APIs are powering other sorts of augmentative and chat products, and so I think it's not quite clear where that'll fall out. I think the underlying factors that lead people to use the technology in different places, whether it's chat and API, are probably fairly similar. But maybe there's some things like, for example, regulation, which would mean that legal or medical use cases might be, you might see more of those in the API. But it's really, I think, not quite clear. But I think that the end state of any project to understand the impact of AI on the economy needs to really get a comprehensive picture across all the different surfaces.
Over here.
Sorry, I have a mic here.
Oh, okay.
Sorry. Alex, this is amazing work. Thank you so much for doing this. I was curious, like, if there's insights at the user demographic level in itself, in what users are self-reporting as their profession. Did you have to do some deduction for what their profession was? And especially curious for how this usage varies by age groups and if there's some interesting insights there.
Super interesting questions. Because we are really trying to, as a company, we put privacy very, very front and center. We don't really join on, occupations or age or things like that in these reports, and would want to be very careful about doing that. So we don't have that information. We just have basically the inferred task, and from that we map it to the occupation. But again, it's very possible that someone doing statistics work might not be a statistician, right? That said, we think it's still interesting because it tells you about potential impacts on the statisticians' jobs, and also on the potential demand for labor for statistician labor. But I think that it would be really interesting, especially if there are a way to do that in a good way to have those insights. Thanks.
Do you think you're going to create like social profiles for your users, like outlining their demographics based on their usage pattern?
That's not. I don't quite know what that means, but yeah, that's sort of not. Not.
Never mind. Sorry.
No worries.
Follow-up question. I'm Alma. I'm really interested in this like idea of kind of like tacit knowledge. So obviously this is like really amazing work breaking things down by tasks, but obviously jobs are a lot more complex than just the tasks they kind of boil down to. So I'm wondering if you guys have outlined like an empirical strategy to try and understand the tacit knowledge that Claude could help with, or if that's just not something that AI is going to be able to touch, and also like whether there is kind of a strategy to understand the Claude API impact on like team productivity dynamics. Yeah,
productivity is really interesting, and there's some ways that you might imagine doing that, but many might involve partnerships where you actually get access to the data and see where it's being used, and I think that would be pretty interesting. Your first question was around tacit knowledge. Oh, yeah, tacit knowledge is sort of a thing where if the model doesn't get it and gets it wrong, you might imagine a follow-up question that's like, can you do this better or right? And so that might pop up, if it doesn't pop up in ONET, it might pop up in the bottom-up data set that we collect.
And to the thing that Alma initially asked and the other person, understanding better who's using it, would you be open to like surveying your users? Do you do that from time? You must do that, and send out a survey and have them opt in and say, okay, yeah, I'm a statistician or I'm an accountant.
It's an interesting idea, especially if you could imagine like seeing whether it's representative, right? And hopefully all the survey researchers aren't the only ones that are like, yes, I'm a survey researcher. Yes.
I love answering surveys.
Yes. But no, you could probably cross-reference it by looking at whether the distribution of users who opt in give a representative picture of the tasks you have. So
yeah, it would be interesting to know which of those users are actually using.
Yeah, it's nice.
I think Kathy.
Hi, Alex. Thanks a lot for a great presentation. I just said a lot of your data is at the individual level, and I was wondering if you'd looked at any kinds of, or if you're able to look at some sort of group implementation. For example, a hospital getting all their anesthesiologists to use Claude in a particular way.
Super interesting. We haven't done that, but I think it would be pretty interesting, especially when you start thinking about the organizational level, and if you were able to get at productivity impacts or downstream impacts on the actual ways in which the technology is being used and the impacts it's having. Yeah.
I know we have some online. Let's get them involved here.
I'm going to group a few questions because a lot of them around automation and augmentation, and a lot of sort of conversations happening now about coding in particular being something that ends up being mostly done by AI. So do you have thoughts on what's kind of happening right now in terms of different projections for automation of like most coding tasks in some cases, and other cases saying, look, there's a decline happening in hiring of machine learning and data engineering and all those people. So if you could comment on that, please.
Yeah, that's a great question. That's one of the main reasons why we were doing that work, to try to understand the impact of AI on coding and software engineering. And so, what we see is that usage is much more people with Claude code who are trying to execute and complete tasks, directly. Now, at this point, Claude code is still a person who's sort of directing that work, right? And so, what we aren't seeing is sort of like, maybe people are getting more productive, but I think the impact so that's how the sort of texture of the job is changing, right? The tone of the job is, for people who are adopting these technologies, is much more like, all right, sort of riding the wave with the model. The model is sort of doing things and you're sort of directing it. The impact on jobs is a big question. You need more than just whether people's productivity is increasing. You need to understand, say, the demand elasticity, right? Because you need to know, okay, if it's cheaper to get, X number of features a week, will a bunch more people be like, now I want to do, my huge backlog of feature requests, I want to do it now that it's really, really cheap, in which case you might see an increase in demand. Or if the demand is sort of relatively inelastic and it's sort of really, really cheap, and now you're like, well, great, I still have the same amount of coding I want to have happen, then maybe there's less demand for human labor, right? Now, coding, I think, is one of these big industries where it seems like there's a huge amount of latent demand, but you also have other sorts of factors like businesses looking at what other businesses are doing, needing to establish a strategy for their boards or for the general public and company. And so there's these sort of behavioral economic factors that sort of occur on top of it, which make it just a little bit harder to understand and predict. But hopefully this data gives a good picture of how it's changing to help a bunch of economists figure that out.
And this is a follow-up question to that one, which is like, have you sort of thought about any sort of early signals that you're tipping from that human in the loop space, which we're talking about now, to that full automation space? And how should sort of different sort of companies and others sort of think about workforce development in anticipation of some of these things sort of tipping into that space of full automation?
Yeah, I mean, one thing that people do, and I'm sure there's sort of organizational economists who can answer this better than me, is look at what does the actual production function look like in a company? What are all the inputs? What are the outputs? What are the steps and processes? And how can that be reshaped when you introduce AI? Right? If you were to map, if you have all these tasks that need to get done, and now all of a sudden one person can do more of them because they have AI to help them, then maybe that cuts out certain bottlenecks, right? Or maybe that means that the models can be useful in different ways, right? At the same time, you want to then pay attention to how much are people enjoying that work, and is that work sort of, how does that fit in with the broader strategy of skill development? If people are using AI, are they getting better and getting better at using it? Are they gaining more domain expertise and knowledge? Those are all sorts of questions I think you'd want to ask if you were thinking about how it affects a company.
Well, on that, I mean, how about outside of the this project at Anthropic? You guys do a lot of coding. Dario, your CEO, talked about some very large percentage, maybe 100% of code being created by agents within a year or two. Are you seeing? Can you speak to that? Are you seeing people having the agents do more and more of their coding within the company?
N equals one, but I certainly see it for myself, right? I'm definitely one of the earliest adopters. I'm always trying to like push the technology a little bit past what it can do, and you know, it's interesting when a new model or like Claude Code comes out and you push, and you just sort of keep pushing because it can do a lot more than it could do before. So I definitely see that.
We hear anecdotally a lot about less demand for coding and coders as a result. So there's augmentation as well. Are you seeing that in the marketplace?
I'm less of an expert on the sort of marketplace dynamics, and I'd probably want to turn to like job postings and requests there. I think coding is one of those areas where there's a really deep amount of demand for coding and software engineering, and so certainly our team is still hiring, right? For example, plug for anyone in the audience. It's because I think there's a lot of things that people do that complement what the models can do and bring taste and execution, ideation, and in-person, skills. And the models are not perfect coders; they still make really silly mistakes. So.
Thanks. My question is about repeat use. So the user account of these individuals. You can't reveal it, I understand. But if I reflect on my own use of these systems, I try a lot of things, and then occasionally I hit something that's really useful, and I keep doing it. And so if you were to look at my profile across time, you'd find some distribution of things that I do, but you'd find, for example, I'm trying to bone up on my Spanish, and just having conversations in simple Spanish with the system is something I keep coming back and doing a couple times a week. So if you thought about how to use cross-time, repeat use, and non-repeat use by users to get more information, for example, it'd probably help you tell whether somebody is an occasional statistician or a professional statistician.
Or really loves doing stats at night, when everyone's gone to bed. No, it's true. It's true. I think it's pretty interesting. So you might imagine thinking about, are there super users, right, who are really going deep and using. We haven't done any of that sort of user level analysis. I think there's probably ways you could do it while still upholding the sort of strong privacy guarantees that we have been in this work, and it's definitely really interesting, and I think would paint a different sort of picture as of the impacts of AI.
Are you gonna ever have a way for us to upload like audio files and MP4 files versus just static files?
Is this a Claude feature question?
Yeah, this is a Claude feature question because I tried it on other AI. And they don't let you do it. So
I unfortunately know nothing about our future, current and future product development, so I can't share. But it sounds like a nice feature. I'll take it to the team.
Hey, my name is Christian. I had a quick question for you. So whenever we have these horizontal problem-solving toolkits, right, like LLMs, something really important in AL is the iteration cycles. Right? Because everyone has all these like custom requests. And so I was like really excited looking at one of the graphs you had around like there just being this huge amount of people that are just iterating alongside the product. But it also can kind of backfire, right? It means that like the product's not doing the thing the user wanted. So I was just wondering if you had any, interesting ways of framing this that brought some clarity.
Yeah, I mean, it could be that a person is not, getting what they want from the model, right? If they're trying a lot, it probably means that they think the model at least has the potential to do that, right? Otherwise, that sort of usage would fall off. Or it could also mean, you did what I wanted. Now let's do the next step. Now let's do the next step, right? So I think I tend to view, people don't tend to like being repeatedly frustrated for a long time, at least unless they think that there's some like rarer but high payoff. And so I tend to still think about it from that sort of positive side there. But you could also imagine, complementing that with user surveys or something to see.
So you briefly flashed up a little bit of time series. Was it only 2 months? Is that right? Okay.
Yeah.
Maybe you could just say a little bit more about. That seems like a particularly interesting thing. Is how it's evolving over time and how usage is evolving over time.
Yeah.
To Tom's question, like an individual user may start progressing and using parts of it much more than others. Because I do think you could imagine the population as a whole, individual users first kind of experiment. And probably most people are still kind of in somewhat of an experimenting mode, but then over time they start gravitating towards things that are especially useful. So I guess talk us through this a little bit.
Yeah, it's a great question. I think one of the big things we want to do is this longitudinal analysis over time of looking at changes. This is the only analysis we have so far, but even in 2 months, these are a million examples, right? So all of these numbers are at least statistically significant, or other sources of data of variation dominate them. So yeah, I mean, we're seeing sort of an increase in the use cases that people have already been using the most, right? So sort of representing like, this seems to really be working. A lot of people are now, have been writing code, are going to sort of do more code. Physical and life sciences, doubling down on that. How it'll change, if you imagine seeing a new modality, right? If you were to imagine like something like audio or something like that, maybe you would see totally new sector of the economy sort of have an increase, right? One of the things we were wondering if we'd seen is if you saw the new reasoning technology, right, that was released. Well, it did coincide with an increase in computer and mathematical use cases, which is where you see the most amount of usage there. Could that be connected? That could be one way that you could see. But I think we really do want to track that over time. And that might give us sort of an early indicator of, oh, wow, there's this new emerging use case that's going to be hitting the market soon.
Right. So is this graph here just representative of a increase in users, or is it a real?
This is a proportion, right? So we don't look at absolute growth or numbers, right? This is just how does the proportion change?
Yeah, on that point, successful as your company is, it's still a tiny fraction of Americans use it, and maybe and so this is not like 40% of people in coding are using it.
Yeah.
So we talked a little bit before your talk in my office a little bit about how this might play out through changing in productivity and so forth. The numbers are still probably too small to move the big productivity numbers, but you were more optimistic. Maybe you can just tell us why you were optimistic about some bigger productivity numbers coming from what you're seeing.
Yeah, I mean, I think it's still sort of early in terms of a lot of the technology is still improving a lot. More people are starting to adopt the technology. People are figuring out the right product surfaces and anchors. So I think there's a huge product overhang, right? The models are incredibly capable at a bunch of different tasks. They just haven't been given the quite right access to the tools and data and infrastructure in order to realize them. And I think something like Claude Code is an example of how to do that. There's a whole bunch of other products that people are making that are doing the same thing. And so I also think that AI is one of these technologies that's really unique because it has the capacity to facilitate its own adoption. It has the ability to do market research, to design new interfaces, to see how users like it, to update itself, and the sort of recursive process of an ability of models is something that's very unlike past technologies, and which makes me think that we'll be seeing at least more widespread deployment, use, and utilization of it, if not productivity.
So we have a question online here from Peter Kihon. Have you compared your results to the predictions made by OpenAI and Nalando et al. That you put up a little bit earlier about which tasks are being affected, and what they thought was the potential and what you're seeing is the actual?
Yeah, that's why we were just talking about this in your office earlier. Yeah, I think when you look at various projections of what AI could do from a few years ago, especially this paper, GPTs or GPTs, which looked at skills and the overlap between what an AI thought it could do and the various skills that exist in ONET, for example. We tend to see lower usage in our data in areas like healthcare, which, an AI, thought that, oh, I'm very good at healthcare usage, right? And so those occupations were marked as high exposure. But there's lots of organizational and cultural barriers to adoption. So we see lower usage there than maybe was predicted a few years ago. On the other hand, we actually see much higher usage in math and science use cases than was predicted. And that's because, a few years ago, people didn't really think that these models could reason and could do, math and science tasks, right? Whereas now you have new work coming out that's proving unsolved theorems and identifying new counterexamples to mathematical conjectures. And so that's a sort of difference where we're actually seeing more usage than was previously predicted. And I think is just a good indicator of why, now that we have real world data, it's maybe a bit more informative than some of the things we've been able to do in the past, which were, of course, really invaluable when we didn't have that.
Great. Another question right here. Yep.
So the adoption of AI in a very general sense within industries is not without precedent. I mean, if you think a couple of years back, in the medical industry in particular, or in farming, you have computer vision systems that were used pretty substantive to, augment detection of lesions, that sort of thing. And the changes that we observed there is that humans and AI mostly work together. There were predictions earlier that it would replace radiologists outright. Nobody would train as a radiologist anymore, but we haven't seen that. Can we expect that the adoption of this new wave of AI, LLM-based AI, will have similar effects, or are we dealing with a fundamentally different beast here?
Yeah, I think there's cases in which it's similar, cases in which it's different, right? So if you were to just bundle the technology in an API with a fixed prompt, right, and give it an input and have it render a judgment, that looks a lot like the technology for, say, detecting lesions in various medical images. But the sort of chat use cases are a whole different beast, and agents are even different still, right? They're sort of much more deeply embedded in the work, and they have all of these different affordances that those previous models weren't being given, and they're much more general purpose and much more capable of basically finding their own way to fixing a problem, even if rather than just a single shot decision. I think it is really a fundamentally different type of technology. That said, there will be a lot of lessons from the deployment of AI previously and in past technologies, including the internet, electricity, the steam engine. But I think that there's ways in which it's really a fundamentally different beast.
Time for one more question. Okay, there's. Do you? Yeah, okay, go ahead. Oh no. Okay, all right. There are quite a few online. So one of them is. The task distribution in occupations ONET is changing over time and maybe going to accelerate in part because of AI. Have you thought about what this might portend for changes in the task distribution going forward, not just how much it's doing these existing tasks?
Yeah, it's a great question. It's one of the main reasons why we released this new bottom-up data set, which I'd really encourage folks to explore because it's really quite interesting. It's sort of these 600 granular task clusters with frequencies. And that's where we're really hoping to capture, the tasks of the future, even if ONET really doesn't quite keep up or adapt quite as much. We're seeing things like making interactive physics simulations that use AI, right? So ways in which that wouldn't quite fit into ONET, but it's sort of at the intersection of physics and AI and education. And I think we hope we'll see more soon.
All right. Well, thanks so much, Alex. Really appreciate you joining us. Amazing work.
Thanks, everyone.
And next week, our speaker is Alex Lipton. It's Memorial Day, so the talk is going to be on Tuesday at noon back here. Again, Alex Lipton. Thanks very much.